Imagine for a moment you stand at the edge of Earth, facing the pitch-black night sky. Before you lies an endless expanse of space. No sound, no air, only darkness pierced by starlights, some of which may have died millions of years ago. Yet their light still reaches us today. This is space. Silent, cold, yet mesmerizing. It is not merely the backdrop to our world. It is everything, the home of stars, planets, galaxies, and even time itself. Humanity has gazed at the sky for thousands of years. We've named the stars, woven myths, and built calendars from celestial motions. But only in the last century have we truly begun to enter space. And from there begins the grand story of humanity's journey into the cosmos. Chapter 1. The Birth of the Universe. Everything has a beginning, and our universe began its journey about 13.8 billion years ago. The event known as the Big Bang was not an explosion like a bomb, but a rapid expansion of space that created time, space, and matter itself. In the first moments after the Big Bang, the universe was incredibly hot and dense. Subatomic particles burst into existence, colliding in a chaotic frenzy. Within minutes, light elements like hydrogen and helium formed the building blocks of the first stars. Then came a long darkness, called the Cosmic Dark Age, a time when light couldn't yet travel freely because electrons and protons hadn't stabilized into atoms. But when the first atoms formed, light finally streamed freely. This is what we call the cosmic microwave background, a faint echo of the beginning of everything. Chapter 2. The Birth of Stars and Galaxies. As the universe cooled and expanded, gravity took over. Giant clouds of gas began to collapse under their own weight, forming the first stars. These stars, called Population 3, were massive and hot, burning fast and dying in cataclysmic supernova. From their deaths, heavier elements were scattered into interstellar space. These were the seeds of life. Galaxies began to form from majestic spirals to enormous ellipticals, building the massive structures that fill the cosmos. Galactic filaments, vast walls, and immense voids. Chapter 3. Planets in our solar system. Around 4.6 billion years ago, in an unremarkable corner of a spiral galaxy called the Milky Way, a gas cloud collapsed to form a new Star Wars sun. From the leftover material, planets, moons, asteroids, and comets formed. Earth, the third planet from the sun, began as a spinning ball of fire, but over time, it cooled, forming oceans, an atmosphere, and eventually, life. Chapter 4. The Evolution of Life and Consciousness. From simple molecules in the ancient oceans, life slowly emerged. Single-celled organisms evolved into complex beings. Dinosaurs ruled, then vanished. Mammals rose to prominence, and finally, humans appeared. But humans are more than biological creatures. We are curious. We look at the stars and ask, what's out there? That curiosity drives us to explore, to understand, and to dream beyond Earth itself. Chapter 5. The Exploration of Space. In the 20th century, humanity fulfilled ancient dreams, launching artificial objects into space. Sputnik, Yuri Gagarin, the moon landing, Hubble telescope, International Space Station, Mars rovers. We began to understand that Earth is just a pale blue dot in the vast dark sea. And now, we send robots to the moons of Jupiter and Saturn, searching for life beneath icy oceans. Chapter 6. The Mysteries of the Cosmos. The universe still holds secrets. What is dark matter? Dark energy. What lies inside a black hole? Is our universe the only one, or just one of countless others in a multiverse? Science advances constantly, but the more we learn, the more questions we uncover. Chapter 7. Humanity's Future in Space. Colonizing Mars, permanent bases on the moon, exploring Titan, Enceladus, and Europa, missions to the nearest stars, harnessing solar energy across the globe, and one day, perhaps, we will leave the solar system for the stars beyond. Chapter 8. Black Holes, Gateways to Uncertainty. Black holes are among the universe's most mysterious objects. They form when massive stars run out of fuel and collapse under their own gravity. The result is a point of extreme density and gravity, so intense that not even light can escape. At their center lies the singularity, a point where known physics breaks down. Surrounding it is the event horizon, the invisible boundary beyond which there is no return. Some scientists speculate black holes could be gateways to other universes or time machines, but for now, these remain in the realm of theory. Chapter 9: Dark Matter and Dark Energy, the Invisible Majority. All the stars, planets, and galaxies we see make up only about 5% of the universe. The rest, about 27%, is dark matter and the invisible substance we detect through its gravity. The remaining 68% is dark energy of force, driving the accelerating expansion of the universe. Dark energy is a profound mystery. Why is the universe expanding faster? What is the source of this energy? Will it cause the universe to stretch so far that light itself can no longer reach us? Of all we've discovered, it is the unseen that dominates our universe. Chapter 10: The Multiverse. Are we just one among many? The idea that our universe is only one among many may sound like science fiction, but in theoretical physics, it's not so strange. Some models of cosmic inflation suggest that universe bubbles may continually emerge in a vast cosmic ocean. Each universe could have different laws of physics. In some, gravity may be weaker, light might move slower. Some hypotheses even suggest alternate versions of you exist living different lives, based on different choices. We may never be able to prove it, but the possibility of a multiverse invites awe and reflection. Chapter 11: Life Elsewhere. We haven't found life beyond Earth, but given the universe's size, it seems likely we are not alone. Scientists search for biosignatures, chemical traces, and exoplanet atmospheres that suggest life. We've discovered thousands of exoplanets, some inhabitable zones where liquid water could exist. Major projects like Breakthrough Listen and missions to Europa or Enceladus seek microbial life beneath icy oceans. The search continues. Chapter 12: Alien Civilizations. If life is out there, what form does it take? Microbes, or advanced civilizations harvesting stellar energy through giant structures like Dyson spheres? We imagine much, but one question remains unanswered. Where are they? This is the Fermi paradox. If intelligent life is common, why haven't we seen evidence? Maybe we're too early, or too late, or maybe intelligent life tends to destroy itself before reaching the stars. Chapter 13: Future Technologies. To reach the stars, we'll need radical new technologies. Today's fastest spacecraft would take tens of thousands of years to reach the nearest star. Some concepts in development: nuclear thermal rockets, ion propulsion, giant solar sails, even warp drives manipulating space-time itself to slide faster than light. These are not mere dreams. Scientists like Miguel Alcubierre have developed theories suggesting that interstellar travel may not be impossible. Chapter 14: The Philosophy of the Cosmos. Understanding how small we are among the stars makes many ask, what does it all mean? Are we alone? Are we here by chance or by design? Why can tiny beings like us comprehend the universe at all? Science and philosophy often meet herein. Sometimes they complete each other, because often the answers we seek lie not just in numbers, but in meaning. Chapter 15: Earth, a home we must protect. For all our space dreams, one truth remains: Earth is the only home we have right now. Protecting its atmosphere, biodiversity, and climate is essential, not just for us, but for future generations. Because if we can't care for this small world, how can we hope to reach the stars? We've come far from the Big Bang to black holes, from atoms to galaxies, from microbes to visions of starfaring civilizations. Chapter 16: Planetary Colonization, the first step to the stars. Imagine a new world, Mars's red sky stretching above domes, children playing on a dusty surface, hydroponic farms growing in habitat structures. Mars colonization is no longer a dream, but a real human goal. SpaceX, NASA, and ESA are planning missions to send humans to Mars in the coming decades. The challenges are enormous: cosmic radiation, psychological isolation, oxygen and water supplies. Colonization isn't about escaping Earth but expanding life, spreading the light of human consciousness to untouched places. Chapter 17: Cities in Orbit and an Inhabited Moon. Before Mars, humans may first build communities in low Earth orbit and on the Moon. Giant rotating space stations with artificial gravity could serve as workplaces, labs, even homes. The Moon, being relatively close, could become an experimental base and transit hub. We could mine its regolith, build structures from local materials, and test large-scale life support systems. In time, the first cities might rise in Mare Tranquillitatis, the vast plain where humans first landed. Chapter 18. Human Evolution in Space. If we live beyond Earth for hundreds or thousands of years, we may not remain the same. Low gravity, high radiation, and artificial environments could drastically alter the human body. Children born on Mars may be taller, with lighter bones. We may engineer ourselves to better withstand cosmic rays. A new kind of human could emerge, Homo stellaris, the starborn human. Not just our bodies, but our cultures would change. Songs, languages, and thought patterns would evolve with the worlds we inhabit. Chapter 19. Artificial Intelligence and Interstellar Travel. To explore the stars, we may need advanced AI. AI could be pilot, scientist, and companion in one system. They could chart paths, manage spacecraft systems, and care for human psychology. They may be the first to reach other star systems, not humans, but AI in machine bodies. And if one day we merge human consciousness with machines, the line between us and AI may blur. We may become something new, digital, immortal entities traversing the galaxy. Chapter 20. Time and Space Travel, Possibility or Illusion. Science has proposed theories of wormholes, tunnels through space-time that might connect distant points instantly. If stabilized, they could be shortcuts to stars or to the past and future. But the risks and paradoxes are staggering. If you went back in time and prevented your own birth, what would happen? If we can see the future, does that mean destiny is fixed? Time travel may be more than travel. It may test our understanding of reality, free will, and existence. Chapter 21. Encounter with Alien Civilizations. If we one day meet intelligent beings from beyond Earth, how would we respond? Would they be peaceful or dangerous? Could we communicate? Such a meeting could be the most defining moment in human history. We might feel small or recognize the shared essence of life across the cosmos. Perhaps the encounter won't happen out there, but through a signal, an ancient artifact, or even the realization that we've already been visited. Chapter 22. The End of the Universe. Every beginning has an end in the universe. Some theories suggest the universe will expand until all stars die and matter freezes, the big freeze. Others predict a big crunch, where expansion halts and the universe collapses. There's also the Big Rip, where accelerated expansion tears everything apart from galaxies to atoms. Maybe this universe is just one cycle in an endless cosmic flow. Or maybe this is our one and only chance to live and understand. Chapter 23. Humanity is light in the darkness. In the vast emptiness, one thing makes the universe special. Consciousness, us, small humans on a small planet, who ask, reflect, and create meaning. We are a small light glowing in the cosmic darkness, and as long as the fire of curiosity burns, our journey will never end. We will continue to build, explore, and dream. Chapter 24. What is the meaning of life amid the universe? When we gaze at the night sky, witnessing countless stars, an ancient question echoes once more. Why are we here? Amid empty space and endless time, our existence feels like a speck of dust in a cosmic storm. Yet from that impermanence, meaning is born. Not because the universe gives us meaning, but because we tiny humans on a blue planet choose to give meaning to the universe. Chapter 25. Religion and Faith in the Space Age. Once, we looked to the sky as the realm of the gods. Now, we send satellites, rovers, and telescopes into those once sacred places. But faith doesn't die, it evolves. In Mars habitats or orbital stations, humans will still seek meaning, praying silently or creating new forms of spirituality born from awe of the cosmos. Perhaps then, faith won't be about heaven above, but about a deep connection between soul and star. Chapter 27. Art, Music, and Imagination in Space Colonies. What would music sound like in a vacuum? How would paintings look under Mars's sunlight? As humans inhabit new worlds, art will evolve. There will be songs about lost gravity, poems about two moons in the sky, and dances performed weightlessly inside rotating habitats. Art is a universal language that will unite humans wherever we are. Even among the stars, we will sing. Chapter 28. A Message for Future Civilizations. One day our footprints may be forgotten. Earth cities may fall, Mars colonies may vanish, but perhaps a satellite, a recording, or a message will remain drifting in the void. A voice that says, "We were here, we dreamed, we tried to understand." And whoever finds it, alien or distant descendants, will know that humans once gazed at the stars and dared to love them. Space is not empty. It is full of stories yet untold, wonders yet unseen, and dreams yet awakened. So let us keep looking up. Let us keep asking, exploring, dreaming, because in the vast darkness, it is curiosity that lights the way. This is not the end. It's only the beginning of the next great journey, written in the stars. Thank you for traveling with us among the cosmos. If you like, please leave your comment and subscribe for more.